Now recording. By completing the square method. I say that the majority of the students don't like this method. Okay, I respect. But the problem is in college algebra, in the test, one question say solving by completed square. So you solving by another way, because not completed square, you have no credit. You solve it well, but not with the method is indicated. Then you need to learn this method. Okay, let me try one elementary example. I want to illustrate the idea behind the completed square. Okay, look at that. Suppose this, example one. X squared plus 26x minus 27 equal to 0. Okay, this is easy by factorization, I suppose. But I want to apply a square root, complete the square, complete the square. Okay, that's what is the idea behind this. Okay, look, the antique mathematician, unbelievable, in the 16th century, don't know very well the algebra that we know today. That this manipulation that frequently we are doing in this moment was science fiction. Now they thinking different, logical but different, and thinking geometrically. Entonces now, for example, I want to explain this because this is the idea behind completed square. And I suppose that this is shortcut can help you to remember very well this method. Okay, after we are doing more complicated example, and you see the idea. So mathematicians believe that x squared look like a square, like that. And the size is xx. And the area in between this is x squared. Makes sense, right? Geometry, basic geometry. Now, to continue with the second guys, 26. You split 26, so you divide by 2, because you can interpret it. You can interpret it a rectangular like that. And which this side is x. It's the same, no? This is x, but this is 13. But twice. Because you split 26 divided by 2 is 13, and 13x is this and this. This is another rectangle similar, but I put vertical, but the side is x and the other side is 13. But this area is 13 times x, and this area is 13 times x. And together is 26. Now I need to complete the square. Wow, what mean complete the square? Find this square. Okay, obviously it's easy. This segment is 13 horizontal, and this segment is 13. Entonces this area is 13 times 13, que es 100. 168. No? I complete the square, and we have a new square. We have a new square. Okay, the area is, I don't know. We have x plus 13. Look, the manipulation is x plus 13 squared. O sea, in this part, in this direction, and in this direction, it's the same, no? And this is equal, well. So basically, 27 do not participate in the game. So x squared plus 26 plus, I introduce artificially 169. Now, I move 27 to the other side, like a 27 positive. plus 169. That you put 169 both sides because this is the magic number. Magic number. Okay, you using to complete the square. Ajá, entonces 27 and 169 together is 196. Ooh, entonces you square root both sides. This is square root method again because I did the factorization this way. You have x plus 13 is equal plus or minus 14 because it's square root 196, 14. Entonces x is equal minus 13 plus and minus 14. Okay, we have actually two solutions. The solution are minus 13 plus 14, que es 1. Wow, fantastic. And negative 13 minus 14, que es negative 27. Okay. Okay, so basically, we come back to the geometry problem. If my area of this big square is 169, it's because the side is 14. So you see, for example, x plus 13 equal 14. So this is 14 here and 14 here, 14 here and 14 here. Therefore, the x is 14 minus 13, que es 1. This is the way the antique mathematicians solving the quadratic equation. But what's the disadvantage? This is visual. This is nice. But there's no efficiency because the negative solution you never see. And the complex solution you never see. Okay, but this I explain this way because I want to illustrate what is the reason of the name by completing the square. Okay, but we'll go in the real life, specifically in this elementary example, we are doing different. We are doing x squared plus 26x minus 27 equal to 0, and the factorization, this trinomial is super easy. Is 27 and 1, no? Because 27 times 1 is 27. I don't care the sign too much. And 27 minus 1 is 26. And the sign obviously is plus here and minus here. And one more time, you apply the zero factor property. Entonces, one solution is negative 27 and another solution is positive. So you solve it in 1 second. Pero no, this depends on the problem, no? Depending. Some problem is easy by factorization. Some problem, no. It's impossible doing by factorization. So let me explain different example of the completed square in order to you get the idea. But not geometrical, no. Let's study in detail the procedure. The procedure is, look at that. Example number 2. Suppose this example, x squared plus 4x plus 10 equals 0. Okay, number 1, step number 1, this coefficient, this number, this constant, do not participate in the completed square. Now you copy x squared plus 4x plus, you put a box, because inside the box we put the magic number. I put minus 10 plus another box. What is the reason that we have 2 boxes, Professor? Well, because you introduce artificially one number to complete the square, you need to introduce the same number in the other side in order to keep the equilibrium of the equation. And the formula of the completed square is you take the coefficient b, que is a linear coefficient, divided by 2. I split in the last example, que es 26 divided by 2, 13, no? But in this case, no. In this case is 4, b is 4, divided by 2 is 2, and 2 squared is 4. It's a coincidence. Not always happen, but in this example happen. Okay, the magic number is 4. You put a 4 here, and you put a 4 here. Do you follow me?
Yes.
Yes,
Aha.
Professor.
This is the formula for the magic number that helped me to complete the square. Okay, and the other example, was 26. You always split into part and a square and give me the area, so this, in this example, that part is b over 2 squared. That part. Okay, but okay. So now, magically, this part is a perfect square trinomial, and the factorization is not two parentheses. No, only one, because they are identical twin brothers, x plus 2 squared. Where come from these two? Square root 4. Where come from this x? Square root x squared. In the right hand side, we have minus 6. Okay, now ready to apply square root method. X plus 2 is equal plus or minus. Don't forget plus or minus. In this case, I radical 6. Radical 6 is impossible. Simplification more. It's irrational and complex. So x alone is minus 2 plus or minus I radical 6. Boom, final answer. You follow me?
Yes.
Okay, I bring a for example to cover every possibility of the completed square. Example, what was the number? Example what number? 3. Example 3. Well, example 3 is x squared plus 6x plus 18 equal to 0. And the order is solved by completing square. Okay, I respect the command. I try to do my best. What should I do? Who help me?
You need to move 18 on the other side.
Exactly. Elsa say, can you move 18 to the other side? Now ready to complete the square. This is the manipulation I want to see. Okay, so what is the formula for finding the magic number?
B over
6
2.
divided.
Excellent. B over 2 squared. Who is B in our problem?
Sí, 6.
6. The 6 divided by 2 is 3. And 3 squared is 9, no? This is the magic number. I put it here in different color to emphasize. You put 9. 9 was the magic number. Now ready. This is the perfect square trinomial. Perfect square trinomial. And the factorization is only one parenthesis, is x plus 3. A squared. And the other side, we have negative 9. 18 and 9, subtraction. Now apply square root both sides. This is x plus 3 alone. Is equal plus or minus. Don't forget this plus and minus. Okay, when you apply a square root method, or when you put plus and minus. Okay, plus and minus 3i, because it's imaginary number. Now final answer is minus 3 plus and minus 3. Supposing Alex, in Alex you listing is solution set is minus 3 plus 3i, separated by a comma, minus 3 minus 3i. You see, for this complex solution, the complex solution is coming by couple of conjugates. It's easy.
It's very easy.
Well, that's why I want to complicate your life now. Let's see example in which the coefficient is no one. Suppose 2x squared minus 13x plus 6 equal to 0. Okay, this is a little bit more complicated. This is an coefficient. So look at the difference between this example and the previous example. In the previous example, the coefficient here is 1. In this case, no. The coefficient is 2. So to solve that, we need to anticipate one step. You create 1 here. So you divide by 2. You divide by 2 the entire equation. No problem. I can do that. divided by 2, divided by 2, divided by 2, divided by 2, divided by 2. So now we have x squared. Unfortunately, 13 is no even number. Okay, so you leave it like that. 13 over 2, x plus 3 equal to 0. Oh, okay. So I have equation very, very similar. The only complication is the fraction, but it's okay. It's okay. So now this is the crucial moment. What should I do in that moment? All right, help me. Well, we are doing the same, no? And the same is help me. You copy that?
Isn't it to move the 3 over to the 0?
Exactly. To the right hand side. You move 3 and you complete the square. So the formula for the complete square is b over 2 square, no? And who is b in this problem? Oh, b is 13 over 2. Yeah, unfortunately. So 13 over 2 divided by 2 is square. Actually, it's 13 over 4, no? Because divided by 2 and divided by 2 again, no? And when you square is 169 over 16, right? Everyone follow me? Don't worry too much for the weird number because we have calculator, no? Okay, now in this moment, I am sure 100%. Okay, our trinomial here is perfect square. Perfect square trinomial. And the factorization is x minus this sign, is important sign. It's always a positive. And the square root of this guy is 13 over 4. Is equal, and we combine together. Let me try. Put it in my calculator. 169 over 16. 169 over 16 like a fraction, minus 3. Or 121 over 16. Now ready to apply square root both sides. Okay, so square root both sides is x minus 13 over 4 is equal, square root 121 is 11, guys, and square root 16 is 4. It's the final answer, plus or minus, don't forget plus or minus. X alone is equal 13 over 4 positive. I move to the right hand side, plus or minus 11 over 4. You separate into part. 13 over 4 plus 11 over 4 equals something, and 13 over 4 minus 11 over 4 equals something. And 13 plus 11 is 24. 24 over 4 is 6. And 13 minus 11 is 2, no? It's 2 over 4, que es 1/2 in lowest term, of course. Final answer. It's the same procedure, except you, first of all, step 0 is create coefficient C1 in the trinomial part. And you are doing it similar to the thing we are doing when the coefficient is 1. No, when the coefficient is 1, I appreciate too much your help. I don't need to do this. However, when the coefficient is no 1, so you need to do something. Okay, one more example. Do you understand very well or no? This is also easy, or I complicate a little bit, no?
It's a little complicated, but I understand now a lot better.
Okay. So help me with the next one. 3x squared. What is your name, Miss? Okay, I like so much your participation.
My name is Annika.
Okay. Okay, what should I do in this example? Suppose in the test, I put this example, I say, wow, completely square method. You need to complete the square method, yes. What should I do? What should I do? What should I do?
Move the 14 over by the 0.
Before that.
Oh, divide everything by 3.
Divide everything by 3. Entonces, x squared, exactly. I need minus 23 over 3 x plus 14 over 3 equals 0. Now, let's doing now the thing you said before. You moving 14 over 3 to the other side. So x squared minus 23 over 3 x plus box by completing the square equal minus 14 over 3 plus the same box. Okay, entonces the formula is the 3. Sorry, the formula is, I remember something as b over 2 squared, right? That's the formula. So you divide it by 2. Divided by 2, who? B. And B is this guy. So 23 over 3 divided by 2 is 23 over 6. Make sense or no?
It makes sense.
And when you square, it's 23 squared, okay, you put in the calculator, of course, it's 529 divided by 36. And this is the magic number. 529 over 36. This is the magic number that completes the square. Do you follow me? And when you are doing this action, Karen, magically, wow, amazing. This trinomial is perfect square trinomial, for sure. I guarantee you 100%. And always happen in the perfect square trinomial. We have only one parenthesis because two parentheses, but they are twin brothers, the same. Now it's x minus, because this sign is negative. When this sign is negative, minus. When this sign is positive, positive. And always this is positive because it's negative, it's no perfect square. And the square root this guy, and the square root this guy is 23 over 6. Exactly, this is a coincidence with this. Always. In the right hand side, you put in the calculator, 526 over 36. You put in the calculator. And I can do by hand, but no, it's 361 over 36. And don't forget plus or minus. No plus or minus now. You put plus or minus when you find the square root. Now square root. Square root. Square root. Okay, entonces now es x minus 23 over 6 square root and square part cancel out each other. And I put plus or minus, and the square root 361 is 19, and square root 36 is 6. Now finally, x is equal, I move 23 over 6 negative to the other side like a positive, plus or minus 19 over 6. And you separate into pieces. The first piece is 23 over 6 plus 19 over 6 and 23 over 6 minus 19 over 6. Okay, this is 42. 42, no? 42, yeah, 42 over 6 is 7. Wow, I like this answer. And 23 minus 19 is 4. 4 over 6. Okay, you can reduce in lowest term because it's even number 2 term. Wow, final answer. Okay, the complication is the, is the number, but see, I try to memorize the algorithm. The algorithm is number 1. Create coefficient 1. Michael, would you, Alex? Would you what? How would Alex want the answer? No. Alex specification. Alex specification. I suppose que want the answer like that. 7, 2/3. Bang. Is the answer in Alex. Divided by comma. Yeah, I suppose. Okay, entonces now, what is the algorithm? Algorithm is first, number one step. Divided by A, que es this coefficient, divided by A. This is A, B, C. You divide by A. Because I want obtain one new equation que A is 1. Second step is I move the new C to the right hand side. Y I find in one corner of the piece of paper the magic number. You put 2 boxes and put the magic number. And the rest is easy. The rest is perfect square trinomial, apply square root both sides, and baby algebra, and baby arithmetic. Okay, entonces you understand very well or no? Okay.
Yes.
It's very easy.
Yes.
Thank you.
Excellent. Now, entonces, the mathematicians say, wow, too much. There, I can't find the formula. The formula of this. Suppose this, ax squared plus bx plus c equals 0. This is my standard quadratic formula I know every in all my life. To say I can apply a square root method on this? Yes. You divide by A. You divide by A. You divide by A. You divide by A. You have x squared plus b over a x plus c over a equal to 0. Because 0 divided by any number is 0. Is the word yeah, of course. The Mari, I explained at the beginning, Alex is waiting for you, and it's due Halloween day. And don't interrupt me anymore. Focus on this mathematics. I focus. Okay, now what should I do? Well, I want to move this to the other side. Minus c over a. And I create the magic number que complete the square. And remember the formula. The formula say b over 2 squared. Actually it's b, pero b is this in this example. B over a. Entonces b over 2a squared. And by the way, is b squared over 4a squared. So the magic number is b squared over 4a squared. B squared over 4a squared. Do you follow me? Okay.
Yes.
This
Yes.
trinomial, one more time, is perfect square trinomial, and the factorization is x plus, because it's plus here, the square root of this guy gets b over 2a. A squared.
I have a question about the trinomial. Is it always going to be a perfect square?
Why don't you
No
try?
matter.
You enforce it to be. You enforce it to be. The original is not perfect square. But when you put the magic number, this new trinomial is square.
Okay, thank you.
Putting off the microphone, please. Well. Now I try to combine. What is the class code? Hello, guys. Ask this kind of question you are doing particular with me by email. Now we're discussing a complicated, interesting problem now. Okay? The organization, you ask me in particular, you email me. Not necessarily here. Oh, we stay a little bit when the class is over. Okay, so now I want to combine this in only one common denominator. Okay, obviously the least common denominator for is a square. 4a squared. So we have minus 4ac plus b squared. Let me write in different way. Let me write like that. B squared minus 4ac divided by 4a squared. Okay, you apply square root both sides. Square root here, square root here, square root here. And we have x plus b over 2a without a square is equal plus or minus square root b squared minus 4ac divided by the square root, this is 2a. And finally, you solve for x. So it's minus b over 2a plus or minus square root b squared minus 4ac divided by 2a. Oh, it's the same denominator. Nice. There are no reason to write separately. No, I put together like a common denominator, que es 2a. You have minus b plus or minus square root b squared minus 4ac. And this is the famous quadratic equation. Entonces the mathematicians discovered the shortcut to do fast. Quadratic formula. Okay, quadratic formula we are using to solving any quadratic equation. And the test, si no specification the method, you apply always the quadratic formula. Si specification, bueno, okay, entonces now you want by completed square, I need to know completed square. Let's practice quadratic formula, quadratic formula, quadratic formula, quadratic formula, all the time. But you see, the most important thing is that the quadratic formula is coming from the completed square. Do you understand now?
Yes.
Suppose this.
Are you gonna do an example on the on how to make it?
1, 2, 3,
All right,
4.
thank you.
For example, 5. A ver, 1, 2, 3, 4, 5. Suppose example 1 using the quadratic formula. X squared plus x plus 5 equal to 0. Okay, guys, important. To apply the quadratic formula, you need to guarantee that our equation is expressed in standard. Standard, remember, is the right-hand side 0 and organized in descending order. Don't expect that always is given nice. No. Pero bueno, this is example 1, example 2, example 3 is nice, but example 4 and example 5 is not nice. Okay, look. Entonces, your identification. A is 1, B is 1, and C is 5. Okay, I'm plugging in the formula. Look at the formula. Guys, this is extremely important. We are doing today, and the last day in December, we continue doing quadratic formula. Okay. So you plugging in. X negative 1 plus or minus square root 1 square, que es B, minus 4 multiplication by 1 multiplication by 5 divided by 2 times 1. This is my way. I just copy the formula after I replace the variable by the number by the corresponding value. And we focus now in the expression inside the radical. According to the order of operation is the first thing you should do. 1 squared is 1. Minus 20. Where come from 20? 4 times 1 times 5. It's a negative 19. And you apply the square root. It's this big square root. Now I copy short. But this is imaginary. It's I square root 19 because 19 is prime number. It's impossible simplification no more. So far, my answer is negative 1 plus or minus I radical 19 divided by 2. And this is a complex solution because contain I, no? Now, normally, the complex solution, never you write like that. You split this common denominator like that. Minus 1/2 plus or minus I radical 19 over 2. That's the standard way or standard form to write complex numbers. So the complex number, you know, okay, we have real part plus I imaginary part. Separately. No common denominator. Hello. No. Okay, entonces leave it like that. Cool.
Very easy, thank you.
Let's do one more example. Example 2, using the quadratic formula. X squared plus x plus 1 equals 0. Question number 1. This equation is already expressed in standard? Yes or no?
Yes.
Yes. Question 2. Who is A, B, C in this example?
A is 1, B is 1, and C is 1.
Oh, everything is 1. Now I copy my formula. Yeah, substitution into the formula, the corresponding value, everything is 1. And negative 1 plus and minus square root 1 squared minus 4 multiplication by 1 divided by 2 times 1. Wow. Everything is 1. Okay, now I focus use a different color to indicate the operation inside the radical. Is the first thing you should do according to the order of operations. 1 square of 1 minus 4 is negative 3. And square root negative 3 is I radical 3. So far we have minus 1 plus or minus I radical 3 divided by 2 que yo split like that. It's, you can write like that. Yes, but it's no polite. So now when it's complex, you split. Okay, this is the real part and this is the imaginary part. Okay. Look like easy or complicated?
Very easy.
Well, one more example. Remember I said 5 examples. Example number 3, no? Is x squared plus 3x minus 5 equals 0. Question 1. This is quadratic equation, yes or no? Yes. How do you know it's quadratic? Because I see these 2. The exponent is 2, degree 2 is quadratic, right? Number 2, is already expressed in standard? Yes or no?
Yes.
Yes. Entonces now, si es expressed in standard, I can determine directly who is A, B, and C. Otherwise, no. Otherwise, no. You see another example que no. Who is A, who is B, who is C? Tell me.
A is 1, B is 3, and C is minus 5.
Exactly, negative 5. Because the supposition in my mind, I have this format. And we compare this and this. A is 1, B is 3, and C is negative 5. Okay. Now ready. I copy again my formula. Now replace minus 3 plus and minus square root 3 squared minus 4 multiplication by 1 que say multiplication by negative 5. Be careful with the sign. 2 times 1. Again, I focus in the expression inside the radical. And 3 squared 9. Be careful with the sign, guy. Look, double minus, bah, this minus and this minus together is positive 20. It's a 29. Now square root 29. Square root is square root 29. 29, unfortunately, is prime number. We cannot simplification anymore, but it's real. Real, irrational. Real, irrational. And the answer so far is minus 3 plus or minus radical 29 divided by 2. In this case, you don't need to split. You split when you have complex. You have I here, you split. But if you have no I, no necessary split. Okay, either way, you copy. Because it's a real number. This is a real number. Of course, the solution says 2 solutions, no? The first solution is minus 3 plus radical 29 over 2, comma, and Alex, minus 3 minus radical 29 over 2. And close the curly bracket, two solutions. Super. Okay. Now in example 4 and example 5, I bring new situation. And you help me to solve that. What's going on? Yes, okay. Suppose this example. 18, example 4, no? 18x squared plus 2 equal minus 15x. ¿Es quadratic equation, yes or no?
No.
Yes.
No?
Yes.
Yes. Yes. How,
It
what is the
was
glue in quadratic equation? Look at that, 2 here. But it's already expressed in standard?
No, we need to
No.
organize first.
You need to organize first. How you organize?
Move the 15 over to the 18 square and 2.
And you organize in descending order of the degree. Degree 2 in the first place, plus 15, que es linear, and 2. Now it's ready in standard. And we start now. Who is ABC? Who is ABC? In this specific problem.
A is
Say again?
A is 18,
Uh-huh.
B is 15,
Uh-huh.
and C is 2.
Cool. Okay, typical mistake. Some students do not organize first the equation and believe que B is negative 15. Wrong. Okay? Now I'm plugging in, and my famous formula. I copy the formula to be systematic way. Now ready. Minus 15 plus or minus square root 15 squared minus 4 multiplication by 18 multiplication by 2 divided by 2 times 18. Okay, I don't do any operation, only replace. Now I focus in the complicated part. What is the complicated part? The part inside the radical. Of course, I have calculator to do fast. The multiplication. This is 15 squared to 225. And now multiply. Multiply 4 times 18 times 2 is 144. And now subtraction, 81. And now square root. Oh, I like that because it's perfect square and 9. Because I copy now. I did the
Professor,
Uh-huh.
I'm sorry. 16 square is 225?
Yes, absolutely. Put in your calculator, Elsa. 15 times 15.
Okay.
You did that? 15 times 15.
Yes, sorry.
No, I know my memory, but it's okay. Okay, so now the organization, guys, this is important. Negative 15 plus or minus 9 divided by 36. Okay, 36 comes from 18 times 2. Okay, now in this moment, I separate in two pieces. Negative 15 plus 9 over 36 and negative 15 minus 9 over 36. Okay, negative 15 plus 9 is minus 6 over 36, reduce and lowest term is negative 1 over 6. This is my first solution. And this is now negative 14, no, 24, minus 24 divided by 36. We can reduce and lowest term, of course. Divided by 12, I guess so, is 2/3. And the solution set is negative 1 over 6, comma, negative 2/3. So solution for this equation was solution set is real minus 1 over 6, comma, minus 2/3. Beautiful. Any question, guys? I am doing too fast or I am doing well?
You're not going too fast.
Tell me. Too fast? I am doing well? Good. Okay,
You're
all good.
doing well.
One more. Okay, one more example. The last one, I promise, because I want to spend the rest of the time in the other topic. Suppose this x squared plus 1/3 x minus 2/3 equal to 0. The quadratic equation, yes or no?
Yes.
It's already expressed in standard, yes or no?
Yes.
What is the only problem? I try to bring fractions. Nobody working the quadratic equation using fractions. That's what should I do? Why don't you eliminate the fraction? How you eliminate the fraction? It's a classical in algebra. When you have equation that contain fraction, you multiply the entire equation by the least common denominator, in this case 3. No? When you multiply by 3, everything by 3, 3 times this, 3 times this, 3 times this, and 3 times this. That's 3x squared plus 1/3 times 3 is only 1 minus 2/3 times 3 is 2 equal to 0. And this is my new equation. Okay, it's equivalent 100% to the original, equivalent, same solution, but now it's nice because do not contain fraction. This is classical. Classical in algebra, nobody working using fraction. This is totally stupid, complicate your life, totally useless. Now, identification que A is 3, B is 1, and C is negative 2. I'll copy one more time my equation. Okay, replace. B es 1. Entonces, minus 1, some minus. Okay, let me copy here. C es negative 2. Square root 1 squared minus 4. Multiplication by A, que es 3. Multiplication by C, que es minus 2. Divided by 2 times 3. Guys, be careful with the signs. You make a mistake. I make a mistake every day. But if you make a mistake in one sign, you screw up everything. 1 squared 1. And this is double negative. Look at that. Minus. Together. Positive. It's positive. Entonces, positive what? Positive something. Positive. This is 12. 4 times 3 times 2, 24. Oh, 24. It's 25. I like that because 25 is perfect square number. And there's a 5. So far we have minus 1 plus or minus 5 divided by 6. No, you split in 2 pieces because I don't want to manipulate plus and minus symbol. No. I manipulate positive and negative separately. 5 minus 1, 4 over 6 is 2/3. First solution. And this minus 6 over 6, negative 1. Second solution. Solution then of this equation was 2/3. Solution set 2/3 and negative 1. Final answer. Beautiful final answer. Entonces, you feel a little bit strong in the quadratic equation? Yes or no?
Yes.
Yes.
Practice. We have to practice. How you practice? Using doing the homework in Alex. Remember, you start right now, better now, Michael. You start right now, Any question, I am ready for you 24 hours, 7 days. You email me, make a screenshot of the question that you don't know or the question. And be careful because Alex, suppose you are doing well. And when you put the answer, Alex say it's wrong because Alex is a robot, you know. You immediately email me. I can get inside your test or your homework. Yeah, I fix it. Okay, I fix it the score. I say no, it's okay. So this situation happen. No, happen every day, but happen. Okay, so now the next topic that we're discussing is a radical equation. Radical equation. It's easy identification because it's an equation that involves somehow radical. Okay, so basically, what is the key idea for solving radical equation? Let me explain the key idea. Suppose you have key idea. Is you suppose we have square root. Oh, it's identification radical equation. And we have here any expression, algebraic expression, equal a number. Suppose hypothetical 10, 20, 100, either way. Bueno, the key idea is you eliminate. How you eliminate that? Bueno, you square both sides. And you know very well. Okay, square root and square power undoes each other. And you copy the expression any without radical equal 100, no? Because 10 times 10 is 100. And now you continue. This equation is easier than the original. However, this equation do not contain radical. But what is the problem? Okay, the solution for this equation, not necessary. I bring example to illustrate this idea. Exactly 100% equivalent to the original. Therefore, mandatory in this kind of equation, you need to check. Checking potential solution, potential solutions. What is potential solution, professor? Well, the solution of this equation. Entonces, I checking where? In the original equation. Mandatory. This is different than another equation. Another equation, not necessary checking. And this equation is mandatory. Okay? And this situation happens when the root that we have in the equation, the index of the root are even number. You know, for example, square roots have index 2. But the problem is the algebra style. When it's a square root, you don't need to write these 2. So you suppose default get 2. But suppose you have 4 root. Yes. Or 6 root. Yes. Entonces, si es 4 root, you need to raise to the 4 power. So the power is exactly the same number of the index of the root. And what about when the root is odd number? Bueno, it's the same, no? You raise to the any power. However, the most important thing I want to emphasize que in this scenario, we never have extraneous solutions. So when the index is 3, 5, 7, you don't need to check it because it never happened. Back solution, extraneous solution. But the procedure is the same. Suppose you have cubic root of the any expression equal 10. Okay, no problem. I cubic both sides. Same number, cubic. And you copy any equal 1000 because it's 10 times 10 times 10, 3 times. And the solution of this equation is 100% true. And you never need to check it. No. So you want to check it, it's okay. Okay, the checking is always possible in algebra when you have equation, any equation, and you want to verify that my solution is right, that you are doing well, you're checking and you get true statement. But this equation is special. because this equation mandatory checking when the index is even. When index is odd, no. Do you understand this? Okay, entonces I bring 1, 2, 3 examples que illustrate very, very well this idea. Example 1. Example 1 always is piece okay. It's easy because it's the first. Suppose the square root 2x equal. Okay, recommendation for the solution is you rewrite again the equation. Because I want to manipulate this equation. I want to transform it. I want to change. But I reserved the original, waiting for the last moment of the checking. I don't touch this. No. Now, what is the key idea? Square both sides. So my new equation is 2x minus 1 equal 1. Those 1 squares, coincidence as well. Now, this is easy linear equation. 2x equal 1 plus 1 get 2, divided by 2. X is 1. And this is my potential solution. Okay, I need to verify. So in the test, you split the paper into parts, and you check it for x equal 1. Let's do it. Substitution. 1 and the original. So I want to verify, okay, square root 2 times 1 minus 1 should be, I claim that, 1. You replace x for 1 and verify it's true. It's true, because 2 minus 1 is 2, and 2 minus 1 is 1, and square root 1 is 1, 1 equal 1, super cool, super true. 1 equal 1, this is completely true statement. This is 1, sorry. 1 equal 1. Therefore, the solution 1 is the solution for this. So solution set for this equation is just 1. Okay? But not always happen. Now I bring one example in which, surprise, you see que no. You follow me? I suppose the student
Yes.
get with, yeah, the student get with me this intermediate algebra very well remember this, no? And the new student one, okay, it's plain for everyone. Okay, suppose example 2. Example 2 very interesting. Pay attention. Example 2. Wow. Is square roots x plus 8 plus 12 outside the radical equal x. Suppose this example. It's a radical equation because it's an equation que contains at least one radical. Ajá, entonces, what should I do, professor? Bueno, you see que the key idea is a square. But before that, you need to isolate the radical. Now you need to manipulate the equation in the other line to isolate the radical. So I move 12 to the other side. Remember, this is manipulation. The checking you are doing in this original equation. And this is a new equation. Not too much transformation, pero eso. Okay, now the key idea is a square. Okay, entonces now the radical disappear. This was my intention. Now, in the right-hand side, we have x minus 12 times itself. And you, why not FOIL? Because of the multiplication to binomial. X times x is x squared. X times minus 12 is minus 12x. Minus 12 times x is minus 12x again. And minus 12 times minus 12 is plus 144. Okay. What should I do? Well, I don't know. Maybe I combine like Turner. There are no reason. Negative 12 and negative 12 together is negative 24x plus 144. In this moment, I ask by myself, what kind of equation I have in this moment? What kind? What kind? What kind? of equation I have. In this moment. Very important, identification. What kind?
Quadratic.
Quadratic. Quadratic. You see, these two is the clue que give me identification que es quadratic. Entonces, to solving any quadratic equation, I know very well what should I do? What should I do? What should I do? For solving any universal quadratic equation, what should I do?
With the quadratic formula, but that one, you need to organize them.
Okay, okay, I agree with you, but before applying quadratic formula, what should I do?
You need to organize the terms. Like
Exactly.
simplifying the terms.
Okay,
Simplifying now. The
putting a
like terms.
standard,
Yeah.
putting a standard, putting a standard, putting a standard. You putting a standard, like that. En standard, you need to know, must be zero the right hand side, okay, must be zero and organized in descending order of the degree. So there are many ways to do this. However, in my opinion, the best way is you bring down this guy and move, why not, x and a to the right. So it's minus x minus a. And here's 0. Doesn't matter see you put in the right hand side. Or this is the question is nice. The question is not bad guy. It's super easy because you can interchange if you want. You feel more comfortable. Now 0 is equal x squared minus 25x. Get the combination this and this, light term. And this is plus 136, no? 136, yes. Because 144 minus 8, no? Okay, if you feel more comfortable, well, you interchange the term to the x squared minus 25x plus 136 equal to 0, correct? And we focus on the solution for this equation. Everyone follow me so far?
Yes.
Cool. Now,
Yes.
entonces I make a decision, well, you solve me using the famous quadratic formula because it's easy. Entonces, I need to identification who is A, B, and C. Who is A, B, and C in this problem?
A is 1.
Uh-huh.
A is 25.
25 positive, 25 negative.
Minus 25.
Remember, you make a mistake one sign. This is the horrible of the mathematics. Your answer is incorrect. Okay, cool. So now I copy my formula one more time because I need to remember. Actually, you remember already or not yet?
Yes.
Okay, this is important. Okay, it's 25 because we have double minus. So the formula have a minus, you see that. And in our example, B is negative. It's 25 positive together, plus or minus square root. Negative 25 squared minus 4 multiplication by 1 multiplication by 136. Don't be scared with the number because we have calculated 2 times 1. And we focus in the expression inside the radical. And you compute a square root negative 25 square, power is 625. Minus and your multiplication. 4 times 1 is 4 times 136 is 544. Subtraction now, 81. The square root now, 9. Okay, I did fast because I did before, no? In the real life, I dedicate more time, put in the calculator, 625 times 25, 4 times 1 times 136, subtraction, square root. So far, the answer is 25 plus or minus 9 divided by 2. As always, I split in two solutions. 25 plus 9 over 2 and 25 minus 9 over 2. Okay, 25 plus 9 is 34 divided by 2, 17. Okay, this is my first potential solution. I need to verify and the origin. Be careful. And this is 25 minus 9, okay, 16 divided by 2 is 8. We have two potential solutions. I need to verify if both work or doesn't work. Where? I waited for this moment, crucial moment. No checking, 0 credit for you. Because in bold concept, you need to check in 17. Checking x equals 17. Let's see what happens 17. And here you're checking for 8. Okay, substitution. It's just arithmetic. 17 plus 8 plus 12 should be 17. And likewise, square root 8 plus 8 plus 12 equal 8. So the only thing I am doing is replace x for 17 or x for 8. Yeah, I put a question mark because I need to prove that this statement is true or not. Okay, this and this together is 25. And square root 25 is 5. And 5 plus 12 is 17. Okay, therefore 17 is perfect. 8 plus 8 is 16. And square root 16 is 4. And 4 plus 12 is not 8. This is completely false. That means that A is no solution, and the only solution that we have is 17. Guys, there are no rules. Sometimes happen that both solution is good. Sometimes happen that both solution is wrong, so we have no solution. And the most common one is one solution is good, another no. Solution set for this equation is just 17. End the story. Cool? Okay, we have time to do one more example. And that's it for today. Any question, guys? Do you understand? I look at too long. This is not the problem. The problem is you are doing step by step, and you know the step you need to apply, you have no problem. So you need to find or need to memorize the algorithm. The algorithm is number one step, isolate the radical. Number two step, you square. A square allow me destroy the radical. No radical anymore. We have another kind of equation. In this case, quadratic. Super. Quadratic, we are strong. You say that you don't have problem with this. And when you're solving this potential solution, you're plugging it into the original because the new equation is not equivalent 100% to the original. So I need to verify that the solution of the new equation is coincident with the solution for the original. If there are no coincidences, there's no solution. One more example can involve two radicals. This is example 3 of the radical equation. Okay, it's the square root 2x plus 3 minus square root x plus 1 equal 1. This is more complicated because you have two radicals. And unfortunately, some students try to square both simultaneously. This is wrong. You cannot solve it for this way. So you need to destroy one by one. Okay, so now, for example, you isolate. So this is my original equation. Okay, never touch. Waiting for the crucial moment. I rewrite. Okay, the teacher say, okay, I need to isolate at least one radical. Either way, you isolate the first or the second, doesn't matter. I move radical x plus 1 to the right hand side, and you apply the key idea, square both sides. Okay. And when you square, this radical is gone. And now we have multiplication binomial. 1 plus radical x plus 1 times 1 plus radical x plus 1. And you FOIL, as always. Multiplication binomial FOIL, always. 1 times 1 is 1. 1 times a radical, bueno, es a radical. A radical times 1 is a coincidence, it's the same radical. And the radical times itself is just the expression inside because it's a coincidence. Look, this is radical x plus 1 and x plus 1. Because you need to remember in intermediate algebra, a radical any expression times radical any expression is equal to any expression. Okay? It's logical, right? Yes or no? No answer?
Yes.
Emily? Okay, yes. Now combine later. 2x plus 3. Well, there are no reason to have one here and one here separately. No. 1 plus 1 is 2. We put in any place. Plus, and this radical is the same. You combine, it's 2 times x plus 1 plus x. So basically, I combine 1 plus 1, I combine radical and radical, is twice the radical. So we have another kind of the radical equation. So this, you manipulate, this is, I call this the first stage, in which you eliminate the first radical, the radical that you decide is the first. Now let's move into the second stage. Okay, you eliminate the second radical. But we are doing something to eliminate this radical. This radical I need to destroy in one moment. How? Again, same idea. You isolate the radical and you apply the key idea against square. So you copy 2x plus 3 minus 2 minus x is equal to 2 times radical x plus 1. I isolated this. Okay, in algebra, this is too long. You move in, combine like term, reduce the sign of the equation. To have 2x minus x is 1x, and 3 minus 2 is 1. Cool. Now ready to square. Square here, and a square here. And this is interesting and complicated because this is binomial. This is x plus 1 times itself. And one more time, you FOIL here. Is x squared plus 1x plus 1x again plus 1. Okay, let me continue with the left hand side. This is x squared plus 2x plus 1 equal. And the right hand side, no binomial, it's monomial. And monomial, you know, so you have ab squared is equal a squared b squared. So you square both. It's like a 2 squared, 2 squared, que 4, no? Not necessarily right like that. It's 4. And the radical square root and square undos each other is x plus 1. But extremely important, you put the parentheses. This parenthesis is crucial. You don't put the parentheses, you could write like that, 4x plus 1. I suppose que 4 multiply only x, and this is wrong because this 4 come from 2 squared. And 2 squared multiply whole thing. And one idea against parentheses is because the radical represent or is actually a grouping symbol. Entonces multiply 4 times everything. Okay, entonces for you apply distributive y no for x plus 4. Wow, too much manipulation, and we have in this moment in one equation, entonces identification. What kind of equation we have in that moment? What kind? What kind?
Quadratic.
Exactly. And what should I do when they have a quadratic?
You need to move the term.
Yeah. So basically, you express in standard, right? Don't
Yes.
explain me clear the step by step. The step by step we are doing the piece of paper. You say, well, you express in standard, professor. Standard is x squared plus 2x plus 1 minus 4x minus 4 equal to 0. And one more time, we combine. 2 is negative 2. Minus 3. Ooh, this is my new equation. Okay, you know, somehow it's equivalent a little bit. I don't know if it's 100% or no. I want to verify with the original equation. Okay, entonces remember, my recommendation is when you face a quadratic equation and this equation is already expressed in standard, you spend 2 seconds to see if it's possible doing by factorization, because factorization is easy, it's quick, but it's weak, not always. The strong method is a quadratic formula. So what do you recommend me to do that? Quadratic formula or factorization?
In this case, factorization is easy.
It's easy. It's easy. What is the combination that open the door for this factorization? I need to know. Go ahead.
3 and 1.
3 and 1. What sign?
Minus 3 plus
Yes.
1.
Because of different sign. Now one solution is 3. And you take this factor. So you take, let me do it again, step by step. You take each factor equal to 0. Es obvio que es 3. The shortcut is you get exactly the opposite sign to the factorization. This is solution, no? And it's a negative 1. And this is the solution of this equation. Okay, I don't know see this equation is equivalent 100% to the original gets given at the beginning. So now to verify this, you're checking for x equal 3, and you're checking for negative 1. It's negative 1, yeah, negative 1. Okay, but this is just arithmetic. Substitution. This is square root 2 times 3 minus square root 3 plus 1 should be 1. Likewise, square root times 2 times negative 1 plus 3 minus square root negative 1 plus 1 should be 1. Let's do it. 2 times 3 is 6. 6 plus 3 is 9. Square 9 is 3. At least that part is 3. Minus 3 plus 1 is 4. And square root 4 is 2. And 3 minus 2 is 1. Cool. Okay. The answer 3 is super. It's super. I put a check mark. Boom. A negative 1. Let's see what happened with a negative 1. Well, negative 1 is, this is negative 2. Multiply 2 times negative 1 is negative 2. And negative 2 plus 3 is 1. Positive 1. And square root 1 is 1. Now here, minus 1 plus 1 is 0. And square root 0 is obvious que es 0. And 1 minus 0 is 1. Okay, both are okay. Now the solution set for this radical equation is 3 and negative 1. Solution. And Alex, solution set 3, negative 1 or negative 1, 3. It doesn't matter the order, right? You write like that. Super. We are doing well today. Okay, we continue next week. Next week, no, Friday. Hello, Friday. I need to, I don't know, see we have time or no. So far, the due date is next Monday for the test and Alex and the test on paper. After that, when the class is over, I want to send the reading test. I want to send the reading test. So you start working with this. See, we have no time because I can move. So I have the authority to move the test, no? At least it's the first, and the first is complicated. Some students don't understand very well. Okay, no problem. When we finish, have a nice days. Okay, bye-bye.